Good morning, everybody. Today I'm going to talk about the project, the activity, the existence of the dark matter in the universe. This is such a wonderful activity. In this activity, you learn about how do you plot the data and how would you analyze it to get the meaningful meaning out of the data. So I would like you to first go through all this, the word here, go through all these pages here, read a little bit more about the galactic mass, how does it changes with the distance. And in this activity you have to plot the different kinds of the scientific, the data. So the first activity, so the first question of this activity is about plotting a graph for a solar system. So this is the distance in astronomical unit, and this is the velocity of the planets with the distance. So you have to plot this graph here, and the data for this graph is given right here, this graph. So you have to plot the distance with the orbital velocity. So this one has to be on y-axis and this has to be on x-axis. How do I plot this one? So this is such a simple thing to do. Here I already have done these things and I'm going to see here. So write down so here I have put all the names, the planetary distance, all the planets here, the distance and the orbital velocity. So this, I took this data right from this graph here. I just copy and paste all the data, or just you manually add all the numbers into your Excel sheet. Okay, and how do I plot this graph here? In order to plot this graph, I've done it already, but I'm going to show you one more time. I'm going to select these two columns, here, go to insert and go to this diagram here. This tells you, you see, this is exactly the same graph here, exactly the same graph. And once you do that, click onto this button and you have axis title and put all the axis titles right there. So what is here on this axis? This is your velocity and the unit should be kilometer per second. Okay, the unit is kilometer per second. And what's this axis here? This axis is your distance r, and which is in astronomical unit AU. Okay, and click here, and this is the planetary distance. With and orbital velocity and orbital velocity. Okay, so once you do that, so click onto again this button here, and you see the trend line. Go to the trend line, select the more options, and you can choose out the different kinds of graph here. Let me delete this one first. Okay, trend line and more trend line options. Not this one, just 1 second. Okay, so here what I'm trying to do is I'm trying to find a curve that fits this all the data points, what you call the best fitted graph here. So I can select these lines and get a trend line, linear, exponentially doesn't fit, linear forecast, moving average. This is close to, or I can go the power terms. When I select this power term, the power, this matches more closely here. Okay, and I'm just going to display the equation here, and you can put the equation anywhere you like, and you can make it bigger too. Okay, so that's the graph. You got it. Once you have this graph, then you need to put this graph onto an Word document. Already have done that one, so I'll just show you how. Let me open this one. Let's plot this graph first. So I did this number part here, number 1. I plotted this graph here. The second, you have to write down what you can see the relationship between the velocity and the orbital distance. What you see here, as the distance increases, the orbital velocity decreases. That's what you have to write down. Okay. The second thing is, now you have to plot the same thing for the Milky Way data. The Milky Way data is given right here. This is the Milky Way data. This is the radius, velocity, and velocity. Okay, so you have to now plot the radius with the velocity for the Milky Way data. Here is the radius and the velocity for the Milky Way galaxy. Okay, all right. So this data, and again, as I said, I got this data right from here. I just choose 1 to 4 to 20. I could have done that one too. Let me, so now in the second case you have to plot the radius and the orbital velocity for the Milky Way data. So I got all this value and put in the Excel sheet here. This is the radius and this is the velocity. So how do I plot this data here? Let me show you one more time. Select these two columns, go to insert and select this graph here, and then here you can plot. This is the plot. But here, and then go to this chart elements, and then you can put all the axis titles. What this axis title is, this is the velocity. The unit is in kilometer per second. This is in kilometer per second. Okay, and this is the distance. This is r, and which is in, the distance is in kiloparsec. Kiloparsec. Okay, and your title has to be Milky Way data. Milky Way data. Milky Way data. Milky Way data. Alright, so this is also done. So in this part here, you got this value here, this graph here. In part 2 you see the trend. Now you got the velocity and the distance graph for the Milky Way data, and then you have to write down what the relationship is. So what you see from this graph here, so what did I see here? There's no any particular trend between with the distance and the velocity. There's no one particular trend. It fluctuates, so there is no any relationship between the distance and the velocity. It's mostly almost constant thing. It fluctuates a little bit, about 200 kilometer per second, but it's mostly constant. or oscillates like fluctuate between 200 and 2050. It doesn't change much. So that's the thing you have to write down here. On number 5, you have to calculate the dynamical mass in terms of solar masses. How do we calculate the dynamical mass? The formula is given right here. This is the formula here. Okay, so you just have to, you know the velocity and you know the distance. You just have to calculate the dynamical mass here and fill in this table here, and you have to fill in this table. Okay, you have to fill in this table here. So I already done this one here, and here is the radius, this is the velocity, and this is the visible mass that is already given, and this is the only thing that I calculated. I'm putting this one, I highlighting these two things. These are the only two things that I have calculated, and I'll just show you how do you calculate this table. This column, and this is given. These three things are given, and I calculated only the things that are highlighted. How did I do this one? Okay, so the way I've done is go to this line and look at the formula here. What is the formula? How do you calculate the dynamical mass? It says 225,000 times v squared times r. So here you just have to place in 225,000 times v squared is the velocity square. So I just square this one. You see in this formula, what you do is put 225,000 times v square. The v square is in this column, so I'm squaring this column times this distance. Click onto this line and you get this one. That's the way I calculated the dynamical mass, and you have to fill in the table. So once you have this dynamical mass, you just fill in this table here now. Just fill in this table. Now for problem number 6 and 7, you have to plot the dynamical mass with the visible mass. So we calculated the dynamical mass, the visible mass is given, and here is the plot. Here is how did I plot it. How do I plot this one with the distance? So what I did, I select this column. You have to select this column, press the control button, select these and select these two columns here, go to insert and go to the graph here, and that's how you plot it. And then you can again level the axis and put the title. Okay, now let's move on to the next number 8. Now what is saying, you have to calculate the visible mass to the dynamical mass. So this is the visible mass, and this is the visible mass, and this is the dynamical mass, and you have to calculate the ratio. How do I do that? So I'm just taking is equal to this visible mass divided by the dynamical mass and hit the enter. Select this one, and this way you calculate the ratio of visible mass to the dynamical mass. This ratio gives you the ratio of the visible mass to the dynamical mass, and you have to fill right here. What you see here, the visible mass is always smaller than the dynamical mass. For any distance, the visible mass is always smaller than the dynamical mass. When you take a photograph, you take the photographs that are sensitive to the only cameras, but there could be other masses which the camera have not detected. So the dynamical masses, which is calculated from the velocity, is always greater than the visible masses, because the camera might not be sensitive to detect the all other presence of the mass, or we call the dark matter. Okay, now and then on number 9, you have to read this paragraph here and answer these questions here. Read this paragraph and answer these questions. Alright, so once you done do that, then the last thing is to finish your to submit your activity. How do you submit the activity? And I'm going to show you how. Let me open. This is so after answering all this question, this is your activity. And here is my answer. This is my answer here. So you have to write down, you have to write all your answer on a separate graph paper and scan this one, attach this one with your original the project. It should not be separated. Okay, so it has to be on the same. So when you scan, do not just only scan your answer, attach your questions, your activity questions too. So this is the activity sheet and here is your answer. It has to be attached together. Okay, so here is my answer, the graph for problem number 1. Here's my problem for number 2, 3, 4, and all the answers are attached here. Okay, so if you have any questions, do not hesitate to contact me and I should be able to help you more if you have any questions. Thank you and have a good time.